Take a look at these solutions. You can clearly see there's a difference in color as you go from left to right. What these are different concentrations of cool blue Gatorade. The one on the right is full strength, the one on the left is plain water. Back in the 1850s, a chemist by the name of Auguste Bier said, I ought to be able to quantify this change. There ought to be some way for me to easily determine what the concentration of a solution is based on its color. So he did some tests and came up with what is known as Bier's law. It basically says that if you pass a light through a solution, some of it will be absorbed, some of it will be transmitted. If you analyze the light that comes through the solution then and find out how much has been absorbed, you can, with a little bit of mathematical manipulation, determine the concentration of the solution just by the amount of light that's being transmitted or absorbed. So that's the purpose of the lab that you missed, and now you're watching the video. We want to pass a red light through these blue solutions, measure how much red light comes through, and then make a graph. From the graph, we can get a line of best fit, and from that, you will get an equation. Using that equation, you should be able to determine the concentration of any other solution of cool blue Gatorade, depending on whether or not it's between about 25 and 100% concentration. Once it goes below about 25%, the crude method that we're using to measure the red light doesn't work so well. So basically what we did in the lab, we used a tablet like this to project a red light through the solutions. So we just put the solution right on the tablet and took another tablet, ran an app, and we took measurements. And so basically there's an app right here, and if you just tap on the little magic wand, it gives a readout that says what the red light transmittance is. So what you've got to do is just get the data table, graph the values for 25, 50, 75, and 100% concentration, make a graph, get the line of best fit, get the equation for the line of best fit, and then there's also a value for the transmittance, or rather the absorbance of red light by this unknown concentration. Your job is to tell me what that unknown concentration is. Now there's a little more to it. You do have to write a report, put your graph, put your equation into the Google Docs and post that onto Google Classroom. Now, as one more thing I'd like to do is to simulate what the students did in lab. They didn't all get the same answers. And so, based on what you say the unknown concentration is, I want you to pretend like the true concentration of the unknown was 40%. So use 40% as the true concentration and then calculate your percent error. So all this is explained on Google Classroom, and if you have other questions, please email Dr. Kemp at andy.kemp@jefferson.kyschools.us. Try to get this done as soon as you can.